Lovely viewers, let's take a quick look at this question. This question we are asked, which of the following molecule is polar? And this question is coming from a polar and what? Non-polar molecule. It is very important for you to know molecules that are polar, molecules that are what? Non-polar. Now, what do you understand by a polar substance? A polar substance is a molecule that there is an unequal distribution. Underline this word. Unequal distribution. Underline that word. Unequal distribution of electron resulting in one end of the molecule being slightly positive and the other end being slightly negative. I repeat, a polar substance is a molecule in which there is an unequal distribution of electron resulting in one end of the molecule being slightly positive and the other end of the molecule being slightly negative. Now, the opposite of this one is what? Non-polar. While polar, there is unequal distribution. Polar, non-polar is what? There is equal distribution. Polar, unequal distribution. Non-polar, equal distribution. That is what it means. Now, there are I have a lot of factors that you can determine the polarity of a substance. I will only give you two. Number one, bond type. Bond type. Is the bond polar? Bond type polar. Is the bond polar or non-polar? Two, symmetry. Symmetry of the molecule. Is the molecule symmetry or what? Or asymmetry? Now, what do you mean by bond type? Like I said, a polar substance, there's what? There is an unequal distribution. It means that if you have two atoms, one of it is negative and the other one is positive, the negative one will pull more electron to itself. It means that there is what? Unequal distribution. But when you have negative, what? The dipole will cancel themselves. So there is what? Equal distribution. For instance, now I have H, a bond between what? Hydrogen and chlorine. And I have a bond between what? Hydrogen and what? Hydrogen and carbon. You can see that chlorine here is what? Negative. Hydrogen here is what? Positive. Hydrogen here is positive and carbon here is what? It's almost positive. It means that the bond between this one now, this one is slightly positive and negative. The bond between this one now is what? There is what? Equal distribution. Are you following? This one there is what? An equal distribution. Chlorine will tend to pull more electron. To itself, resulting to what? A polar bond. So any bond that results in one being positive and the other one being negative is what? It will become what? A polar bond. Now, secondly, is the shape of the molecule symmetry or what? Asymmetry. Now, let's go to the first option. Look at carbon and what? Oxygen. Carbon here, the bond between carbon and what? Oxygen is what? Is polar. Because of what? Oxygen here is negative, carbon here is what? Slightly negative. Are you following? Therefore, oxygen will tend to pull more electron towards itself. So, number one, this one, the bond is what? Polar. Means that this carbon and oxygen is supposed to be what? A polar molecule. But then, we have two atoms of oxygen. It means that what? We have two atoms. This one, this side is what? Negative. So this one now, this one is negative, this one is negative. Both of them will be what? Will be equal distribution. So since there is equal distribution, it is what? Non-polar. It means that if here has 10 neutron, 10 newton, that is the force of it is 10 newton. This one is what? 10 newton. If they want to drag this carbon here, two of them will drag carbon the same. It means that there is what? Even distribution. This one can cancel out, this one can cancel out. The dipole can cancel out. Means what? There is what? Even distribution. Even this what? or equal distribution. So if the bond are polar, as in the case of this one is what? Polar. The molecule, is it symmetrical? If it is symmetrical, it means what? It is non-polar. As it is now, this one is what? Symmetrical. Symmetrical. So this one is what? Symmetrical. Do you understand? So if the bond are what? Symmetrical, it means that is what? If the molecule is symmetrical, it means that what? It is what? It is non-polar. But if it is non-symmetrical, it is what? It is polar. So you first of all consider the bond type, whether it is polar or what? Non-polar. I now go to, if this one now, if it is polar, now go to the second one, which is what? Symmetrical. Now let's go to what? Methane. If you look at the structure of methane, is like this. The bond type, is it polar? The bond type is non-polar. Like I said, this one now, we have carbon and hydrogen. It is what? The bond type is non-polar. So since it is non-polar, this chain is what? It is non-polar. This one is non-polar. This one is what? Non-polar. Check the first one. The bond type, carbon here is slightly negative. Hydrogen here is the same thing. If you look at the dipole moment, you understand. And the chain here is what? Symmetrical. Look at the chain here is what? Symmetrical. This one, they are outward 3D shape. Look at, it's the same. Do you get that? The molecule is what? Has a symmetrical shape, and also what? Has what? Has a non-polar bond. Therefore, this one is what? A non-polar substance. Let's look at water. The bond between what? Hydrogen and what? Oxygen is what? It is what? It is polar. Are you following? Because what? Hydrogen is negative, this one is what? Positive. Hydrogen will tend to what? Drag more oxygen will tend to what? Drag more hydrogen towards its side. Therefore, making it what? An unequal distribution of the what? Of the electron. Are you following? So since it will drag, the bond is what? Is polar. Now let's look at the symmetry. If you look at the shape of water, you discover that this one is like this. This one is on. So this shape is bent. Do you get that? Since it is bent like this, bent like this, it will make what? Unequal cancelling. That is, a dipole moment cannot cancel themselves, resulting to what? Asymmetrical. This molecule is what? Asymmetrical in what? In shape. And any bond that is asymmetrical in shape, the dipole cannot cancel itself. Therefore, it is what? It is a polar. This one is what? Polar. Water is what? A polar molecule. Let's go to carbon and chlorine. Carbon and what? Chlorine. We have already established that carbon and chlorine, the bond type is what? Is polar. Because of what? Chlorine is negative. This one is what? Slightly what? Slightly negative. Call it positive. Alright? Now, chlorine will tend to drag more carbon towards itself. The electron here will have to drag more carbon into itself. Therefore making it what? To be what? To be polar. Now let's look at the symmetrical shape. That is the shape of the molecule. If you look at here, carbon here is surrounded by what? 4 atoms of what? Chlorine. This one is what? Chlorine. This one is what? Chlorine. Therefore, this shape is what? Symmetrical. And any shape that is symmetrical, the dipole can what? Easily cancel itself. Look at it, can easily what? Cancel itself. So if it can easily cancel itself, it means that it is what? It is what? Non-polar. Are you following? In a nutshell, if you want to know the polarity of a molecule or non-polarity of a molecule, check one. Look at the bond type. Is the bond polar or what? Non-polar. If it is polar, it means that the molecule will be polar. But then you need to consider the second factor. The second factor is what? Is symmetry, the shape of the molecule. Is the shape of the molecule symmetry or what? Or non-symmetrical? Are you following? If it is symmetrical, it means that if it is polar and it is symmetrical, it means that it is what? Non-polar. But if it is polar and non-symmetrical, it is what? It is polar molecule. Therefore, our answer is what? Water. Water is a polar one that are what? Non-polar. So for more of this video, do well to like, importantly share and comment. Thank you and God bless you.